Alright guys, we're going to take what we did yesterday and we'll go one more step with it, which is that sometimes when we simplify these rational expressions, we're going to find that we don't have a GCF and we can't factor using the GCF method, but we do still need to factor them. So again, the first goal is factor this thing first, and you may be using the GCF method at first, but sometimes you may go into double bubble. Sometimes you may need to use grouping. You won't ever need the quadratic formula here because finding the roots isn't going to help us. It's only factors that are going to do us any good at this point. So, starting with example A. I can't find a GCF of either of these, so I'm basically going to do what I would if I were trying to find the roots. I would factor them, so I would look for factors of 18 for my numerator that add up to 11. And it looks like if I multiplied 9 and 2, I would get 18, and if I add 9 and 2, I'd get 11. So because my a value is 1, all I have to do is go x plus 9 times x plus 2. I don't need to use grouping. That's just a simple double bubble because that's a 1x squared. In my denominator, I'm looking for numbers that multiply to -4 and also add up to 0 because I'm missing an x to the first term. So I'm going to go with -2 and 2 because that would give me 0 if I added them. So that's going to give me x minus 2 and x plus 2 because, again, there's an a value of 1. See, these are 1s, so I don't have to use grouping. I can just go right to double bubble. Now here is where we actually are able to reduce this because we're noticing that the numerator has a factor of x plus 2, and so does the denominator, so I can cancel those because that's essentially just a 1, right? So now I'm left with x plus 9 in the numerator and x minus 2 in the denominator. Those cannot be factored any further, so that's as simple as I can make it. That expression is now simplified. So again, you're just factoring and then canceling. Example B. Same deal, my numerator, a value of 1, looking for numbers that multiply to 64 and add 2. I'm going to change this one actually to -16. Let me make that a -16. And you all should do the same. Alright, so if I double bubble in my numerator, I should discover that -8 times -8 gives me 64. And -8 plus -8 gives me -16. Alright, so I factor the numerator. My denominator is going to be a couple steps more. So I'm noticing that there is a GCF, and I think it might be easiest if I pull that GCF out. If I factor out of 4, I'm going to end up with x squared minus 9x plus 8, which makes things really easy for me because if I don't pull that 4 out, now I have to multiply 32 and 4 and look for factors of that number that add up to -36, and that's a lot of work. So I'd rather just use a GCF if I can. So this becomes 4 times x squared minus 9x plus 8. And then I'm going to just factor the quadratic there. Alright, my numerator hasn't changed, but my denominator would be the same as 4 times x minus 1 times x minus 8. Right? -8 times -8 is 8, and -1 plus -8 is -9. So now that I see that there are some common factors in the numerator and denominator, I can cancel out an x minus 8 from each. That's going to leave behind a 1. So I will be left with x minus 8 over, and I'm going to bring that 4 back in here for my final answer, so 4x minus 4. We're going to put it back together in the end so that it's not all ripped apart. So once we factor everything and we're done, let's put it back together, and then we'll see that this is our final answer. Okay, last one. Just a bit more complicated, so we're probably going to want to try to use the GCF method as much as we can to make this thing more manageable. I can see that in my numerator, there is a GCF of 5x, so I could pull out that 5x, which would leave behind an x squared minus 49. 245 divided by 5 is 49. And in my denominator, there's a GCF of 7. So if I pull out a 7, I'm left with x squared plus 16x plus 63. And now it's a lot more manageable. I can make a list of factors of negative 49. I can make a list of factors of 63. And I can try to find ones that add up to my b terms. My b term in the numerator is 0. So in my numerator, I'm going to use x plus 7 and x minus 7. My b term in my denominator is 16, so I should make a list of all my factors, but when I'm done with that, I'm going to find out that 9 times 7 is 63, and 9 plus 7 gives me 16, so I'm going to want to use 9 and 7. So I have 7 times x plus 7 times x plus 9, and now I can see that some things are going to cancel here. I do have a 1 in the form of x plus 7 divided by x plus 7, so that cancels, and that's the only thing here that's going to go away. So in the end, I'm left with 5x squared, because remember, I'm going to put this thing back in here, minus 35x all over 7x plus 63.